Hello, this will be a demonstration of Proposition 25 from Book 5 of Euclid's Elements, which says that if four magnitudes be proportional, the greatest plus the least is greater than the sum of the remaining two. It of course must be the case that all four of these magnitudes be the same type of magnitude. So like four lines or four areas or four angles, because it just doesn't really make sense to add a straight line in an area or a straight line in an angle. That makes no sense. So if all four of these magnitudes be the same type, then the greatest plus the least will be greater than the sum of the remaining two. What we're given is magnitudes A, B, C, D, E, and F, such that AB is to CD, just as E is to F, and we're going to say that AB is the greatest and F is the least. And what we're going to prove from this is that AB plus F is greater than CD plus E. So AB being the greatest, FE being the least. That leaves CD and E to be the remaining two. So we're going to prove that AB plus F is greater than CD plus E. What we're going to do is cut off AG from AB, which is equal to E. We can do this because we know AB is greater than E, right? AB is the greatest of the four. So we're going to cut off AG from AB, which is equal to E. And likewise, we're going to cut off from CD, CH, which is equal to F. Again, because we know F is the least, CD has to be greater than it, so we can cut off from CD the segment CH that is equal to F. Now, AB being to CD, just as E is to F, that we were given that, and having made AG equal to E and CH equal to F, we can then substitute these in by a property of magnitudes and say that AB is to CD, just as AG is to CH. Now we have a whole which is to a whole, just as a part subtracted is to a part subtracted. We have the whole AB, which is to the whole CD, just as the part subtracted AG is to the part subtracted CH, which means that the remainder has to be to the remainder, just as the whole is to the whole. That's Proposition 519. So AB being to CD, just as AG is to CH, we can say that GB is to HD, just as AB is to CD. Now, we know that AB is greater than CD, right? We know that AB is the greatest of the four, so it has to be greater than CD in particular, which means that GB has to be greater than HD. This is sort of like definition 5.5, which is what I've cited it as here, that if you have four magnitudes which are proportional, the first be greater than the second, the third will be greater than the fourth, and if equal, and if less, that's sort of like 5.14, but not exactly. So we can just consider this as naturally following from definition 5.5. So AB being greater than CD, GB must be greater than HD. Now, AG being equal to E and F being equal to CH, we made them that way. Then by combination 2, if we add them together, then we're going to end up with equals as well. So we can say that AG plus F is equal to E plus CH. Now, GB being greater than HD, if we then add GB to the one side and HD to the other, then we're going to end up with the same inequality. Again, that's sort of property of magnitudes. So AG plus GB plus F is greater than CH plus HD plus E, which means that AB, which is AG plus GB, is plus F is greater than CD, which is CH plus HD plus E, so that finally AB plus F is greater than CD plus E. And this is what we set out to prove, which means we are done with the proposition, therefore, etc. QED. There is a cool little thing that follows from this proposition. So if we have a proportion such as x is to y, just as y is to z, then how exactly does this go? Well, we know that x plus z is going to be greater than y plus y. So x plus z is greater than 2y. And then if we divide these by 2, again, we're going to end up with equals. So x plus z over 2 is greater than y. So we're going to have x plus z over 2 is greater than y. And what this means is that if you have any two magnitudes, then their arithmetic mean is going to be greater than their geometric mean. Arithmetic mean, you add two magnitudes together and then divide it by 2. Geometric mean, you multiply two magnitudes together and take their square root, which, as we're going to see in the next book, is what y is. Y is going to be square root xz. So we end up with the fact that the arithmetic mean of any two magnitudes is greater than their geometric mean. I think that's kind of neat. Other than that, I have nothing to say about this proposition. So I'll move on to book 6, which is all about similarity. So combining everything that we've just done in book 5 about proportion and ratios with actual geometric figures, so like squares and triangles and parallelograms and circles and angles. It's going to be great fun. So end the video here and move on to proposition 6.1.